So the first, if you like, the first problem that I had when I came along to this presentation was to ask myself, what is a board? Essentially, it's two dimensions. So it's not an element, it's not a form, it's in two dimensions. Typically, it's non-structural, but there are some cement-based boards that do have structural properties and can be used in structural applications. Typically, it's not load-bearing, but there are boards, cement-based boards, that are load-bearing and can be used in that fashion. And they can be pretty much any size. So a cement-based board ranges from a tile, so as big as my face, to as big as this screen or bigger. And certainly we'll be hearing over the next couple of days of boards that are as big as this or larger. Cement-based boards, again, can be used for many applications. When we're talking about cement-based boards, we're not being specific as to what they can be used for. So I have a list here, slates or shingles, and this is slightly biased by the fact that the American market for cement-based boards is massive. It's at least 10%, if not more, of the world's market, and they've typically led in applications, and they have a very slightly different nomenclature for the application. So whereas in the UK we might call them slates on the top of your house, they might call them shingles. We might call it cladding, so on the side of the house they might call it siding. Also sheathing, roofing, obviously these are applications on the outside of your building. They can be used for ceilings. They can be used for interior panels on studs, so the equivalent of wallboards. And studs can be metal or they can be wood. Typically can be used for tile backer boards, so in a wet room or a bathroom, you would be using the cement board on top of a framework, and then on top of that you would put tiles. So it's a completely water impervious backer board for tiles, particularly in wet rooms. It can be used for flooring, and we'll see over the next day and a half some applications of flooring. They can be used for fencing. Some of the more inventive uses for cement-based boards are for fencing, where you can actually mould them into a pattern, very intricate pattern, we'll see that, and they make for fabulous low-maintenance fencing. Bracing, also decorative elements, they can be shaped and decorated, and we're going to be hearing about how you can decorate cement-based boards in our fourth paper a little bit later on from Rebecca Negron. And they can even be made into furniture, and we'll see that a little bit later as well. So, in some ways, the Global Boards Conference has almost a problem in that it's such a wide variety of board types and board applications, but when you see a cement-based board, you'll definitely know what kind of board it is. So, once again, the Global Boards Conference is about cement-based and cement-bonded boards. It's not about gypsum wallboard, which I would say is a completely different category of construction material, which, for the main part, suffers from a couple of disadvantages compared to cement-based boards, and we'll get onto that a little bit later as well. So the boards that we're looking at, once again, are fibre cement boards, also known as panels, sheets, and they are typically abbreviated fibre cement or fibre cement boards, FC or FCB, and they can have a very wide variety of different fibres incorporated into them, and probably a dozen different types of fibres, and I'm not going to be speaking about that. Maybe a couple of our other presenters will. Specifically, in a subsection of their own would be glass fibre reinforced cement boards, with or without EPS beads, and I'm going to show you a little bit of an example of one of those a little bit later. The wood-based or wood particle or wood component-based cement boards, including cement bonded wood particle boards, which are really clasts, and the fibrous version of those, the wood wool and wood strand cement boards. And Eltomation is a company well known for making machines that make those types of board, and they do, I think, have a hand in making those boards themselves. And then again, cement bonded boards, but really outside of the fibre cement board category, you would have the calcium silicate boards, which are cement bonded to a certain degree, and magnesium oxide boards, MgO boards, which again are cement bonded. We're not going to be speaking so much about calcium silicate boards and magnesium oxide boards, but I do want to include here concrete boards, but they also shade into panels and forms and elements. It almost depends on how thick you want to cut off the definition of a panel or a board. Once they start getting thicker, and again I'm going to show you later on in the conference how thick they can become, whether or not they're boards or whether or not they fall outside of the remit of this particular event. Okay, let's move on. So I want to say a little bit about each of those particular types of boards. So the first one of those was the fibre cement board, and this is the largest, if you like, the largest type of sector of our boards that we'll be speaking about. Also known as fibre cement panels and fibre cement sheets. Variety of different fibres, typically cellulose, virgin fibres from pine plantations and so on and so forth, but it can also use recycled fibres if they're high enough quality. It uses Portland cement, but as a nod to the future, there's a possibility that in the future they'll be using different types of non-Portland cement based cements to make fibre cement boards, and that's something that we can maybe discuss a little bit later on. And then of course they're using fillers, could be sand, could be a variety of other fillers, limestone's been used, and then of course water, additives, and then a heat and steam and pressure curing phase, typically autoclave, to form these fibre cement boards that hopefully are quite familiar to many of you. And these are boards that are made by James Hardy, one of the leading proponents of fibre cement based boards. Next we would look at glass fibres reinforced cement boards, and this would have a glass fibre mat on the surface or slightly embedded within the surface of the board. And there are a variety of these products out on the market with lesser or greater levels of sophistication. Again, they use Portland cement. They use those fibres typically within the board itself to give it flexural strength. Fillers, sand, water, additives, heat, steam, pressure. Same again. Here's one example. You can see that this is a relatively unsophisticated board, but it's a glass mat reinforced board, very, very robust. I'm not sure if anybody brought any examples of these to the conference, but they're actually a wonder of technology and how they're made. And here is an example of a glass mat, it's glass fibre reinforced, glass mat reinforced cement board, which also incorporates EPS beads, which makes it lighter, of course. It gives it greater insulating properties, and this is a fairly sophisticated, or very, I would have to say, very sophisticated, very, very robust, high performance, high value added board. And of course, this is the Permabond board from National Gypsum. So, very, very pleased to be able to show that. And as an added bonus, the coin in the top left-hand corner has a picture of our Britannic Majesty's head upon it. So that's nice too. Next one that I want to look at is cement-bonded wood particle boards. Often you'll see these known as particle boards, but they are cement-bonded. And as an example, here's Sembrit's Sem-Panel board. It comprises by weight 69% cement and 31% fine wood particles. So these are particles or clasts rather than strands per se. But it also includes process additives and mineralizing agents. And the ingredients are mixed and laid onto carrier plates, which are stacked and compressed to the desired thickness until the cement is hardened. The boards are then conditioned to bring them to optimum moisture content, and once fully matured, the boards are trimmed and quality inspected. You can't really see the detail on this, but this is these particles are fairly close. One step up, if you like, from these in terms of sophistication would be wood wool cement boards, WWCB. You will often see that acronym, also known as Alto boards, and that's a Dutch company that's successfully exported its technology to a number of companies around the world. This incorporates a wood wool, which essentially is composed of longer strands of wood of various different coarsenesses that can be very, very fine, or they actually can be rather coarse, including up to what they would call strands, which would be several millimetres across. Champagne? Excellent. Once again, it includes Portland cement, fillers, sand, water additives, heat, steam and pressure. And here you have a picture of Alto boards. They can be painted, but they would typically have quite a coarse surface texture upon them, depending, though, on the coarseness of the strands that are being used to manufacture the boards. Briefly, I want to mention calcium silicate boards, typically used in a completely different set of applications to the other boards that we're going to be speaking about over the next couple of days. Cement bonded again, so that's why we've included them in the conference. They would typically be used for high temperature insulation applications, amongst other applications as well. And then once again, magnesium oxide boards, which in some ways are analogous to basic fibre-cement boards, but have some niche applications, and I understand that they're quite often used in film production work. They're very robust boards and fairly lightweight. And then finally, I want to mention these concrete boards, where you would incorporate, what I would understand, they would incorporate some kind of aggregate. And from a concrete perspective, you would have your basic cement, and this is where the American and the rest of the world might slightly disagree on some of these terms. You'd have your basic cement. If you would add sand into that and some other additives, that would make it into a mortar, and if it didn't have the water in it, it would be a dry mix. Put the water in, it's a mortar. You can use that for some applications. But then if you were to use that mortar mix, which already has the sand in it, and then you were to add in a coarser aggregate, then that becomes concrete, a form of concrete. So you're using this coarse aggregate as part of the product. And in America, I know for sure, they often call pavements, or what we call pavements, they call sidewalks. They call them cement sidewalks, but actually they're concrete. So there's a little bit of difference in the terminology here, but my understanding is that concrete boards include specifically an aggregate. Of course, they include Portland cement, as with all of the others that we've spoken about, the fillers, the sand, water additives, and the curing process of heat, steam, and pressure. And as an example of that, I would like to show this graphic of, once again, National Gypsum's Permabase board. Now, Permabase definitely uses sand, as far as I understand, but it also seems to use an aggregate. And in this way, depending on the coarseness of the aggregate, I would tend to start to call this a concrete board, but it's still a cement-based board, so let's include it along with everything else. And I think there might be a debate about nomenclature or whether or not the coarseness of the fractions make it a cement board or a concrete board, but we can do that over a couple of beers a bit later on. Now I wanted to mention briefly some of the properties and advantages of cement-based boards and compare them and partly contrast them to the properties of gypsum-based boards. So cement-based boards, obviously fireproof and fire resistant. They have good thermal and sound insulation properties. They are, and I think this is really one of their prime advantages, they're completely moisture and water resistant or impervious. So you can put them in water for a year and essentially their properties are pretty much unchanged. The same cannot be said for most types of gypsum wallboard. They're impact resistant and sag resistant, but they can also be made to be bendable, very, very bendable, depending on the fibres that you use and the additives that you use. They are typically non-brittle, but you have to compare that to some types of boards, for example, calcium silicate boards, which can be on the brittle side. They are perfectly mould and rot resistant, and that compares with many types of wallboard, unless they're particularly pre-prepared with a kind of biocide. So cement-based boards are completely mould and rot resistant. They're insect resistant. There's nothing in there for insects to eat, and they're a little bit hard on the mandibles anyway. They have very, very fast installation, and they require relatively low skill sets to be installed, and that is comparable to gypsum wallboard, but that's an advantage that they have over brick block work installation construction techniques. They're relatively inexpensive, again compared with bricks and blocks. Depending on the board, they have a smooth finish. So in some ways they can just be painted, or they can be put up, for example, as a siding on a house, and they don't need to be painted. They can be pre-painted in the factory. They can be given a variety of different finishes, and we're going to be hearing a little bit about that shortly. And they can be given extremely sophisticated finishes, and that's something that's to their advantage. The raw ingredients are relatively inexpensive. Cement, sand, water, some of the additives, and they have low embodied energy, so relatively low energy required to actually manufacture the boards, and they, apart from the cement side, they have relatively low carbon dioxide emissions, and there's a graph I'm going to show you a little bit later on which demonstrates that as well. But on the other side, cement-based boards have properties which are disadvantageous, particularly with regards to comparisons with other boards. So some of the additives are relatively expensive. For example, some of the fibres that can be used in cement-based boards can be prohibitively expensive. If you're talking about carbon nanotubes or some of these really not science fiction but more sophisticated fibres, then you're really talking big bucks. Depending on the board, it can have a rough finish. They can be relatively heavy, particularly compared to the lightweight wallboards, which I don't know if you know, but there's been a very strong trend in the United States and progressively around the world, starting from the States, towards decreasing board weights, towards what many call one-man boards, or one-person board, I should say, where one person can pick them up, move them around, and put them in, compared to two that would be required for a heavier board. So typically with a cement board, you would be looking at a heavier board and two people or more sometimes to install them due to their weight. Cutting of the boards can be more involved than for wallboard. You may have to use special tools, for example, and you also have to take particular safety and health measures to make sure that you don't inhale any of the dust, which can be not so good for you. They have relatively low thermal mass, compared, for example, compared to blocks and bricks, but not compared to wallboard. It's a relatively long production process, which is fairly involved, and also there are still proprietary production processes out there, so there are some barriers to entry into the industry, which can be a good thing. So cement boards have particular properties which give them advantages, but also give them some disadvantages as well. Now, I just want to mention briefly the hat-check process, which is also known as the Ethernet process. This is from a paper by Tony Cook, Formation of Films on Hat-checks Machines. And I just want to talk you through this process of making fibre cement sheets. For those of you that haven't seen this, but we will be seeing this in a number of videos through the rest of the conference as well. So this will be, you'll be able to see this in virtual reality, if you like. So, oops, Daisy, that's not right. So the heart of the process is essentially this vat, which includes the fibres, the cement, and the additives. It's topped up via the vat slurry feed, and it's controlled by this overflow. So it has a constant level. Now, there's a rotating sieve here, which essentially picks up a very fine layer of fibres and cement on the outside of the sieve. So this rotating sieve rotates like this. It starts to pick up the mixture from the vat as it comes around here. There's a continuous felt belt which comes around these rollers. It's moving in this direction. And as it comes over onto the top of the sieve, and so it's partially dewatered as it passes up around this part of the rotating sieve. The felt belt comes into contact with the top of the sieve, and there's more of an affinity of the thin fibre cement layer with the felt belt than with the sieve. So essentially, the fibre cement layer comes onto the underside of this felt belt, which then comes over the top. There'll be another dewatering process along here, which essentially sucks out the water. A little bit further, and then there's a process of a forming roller where the fibre cement sheet, very, very thin, will be transferred to the forming roller, which rotates continually like this, and it essentially builds up a thicker layer of fibre cement sheets, number of fibre cement sheets, until the desired thickness is attained. And then there'll be a take-off conveyor here, which, if you like, slices off or takes off the fibre cement board, and then it takes it off onto other conveyor belts and other processes. So that was essentially the hat-check process for forming fibre cement sheets, and it was invented over 120 years ago now, but essentially it's still in a variety of different forms, used exactly the same all the way around the world. And the main difference that you'll see around the world is that there typically won't just be a single vat and sieve. There'll be any number of different vats and sieves that can speed up the process and speed up the formation of the cement boards. And that is the end of my introduction to cement-based and cement-bonded boards. Thank you very much.